Welcome back to our mobility session, which we can share disruptive trends in future vehicle. I'm going to introduce our moderator and our speakers of the panel discussion. Tae-hee Nam, co-founder and managing director at Storm Venture. He's going to be our moderator for today. Robert Seidel, managing director at Mutus Venture. James Gowers, vice president at Perceptive Automata. David Seguera, head of strategic partnerships in autonomous vehicle at Samsung Electronics. John Ford, CEO at TrustLayer.
Hi, I'm Tae-hee Nam from Storm, and really I'm excited about participating in moderating this panel today because this is an area that, especially in the last couple of weeks, I've become personally quite interested in, which is understanding the huge transformation that's going on in the auto industry and in the car in particular. I just got a car about a week ago, and so I'm personally learning all this about electric cars. And it reminds me of the early days of the smartphone. So I'm really pleased that we have a very diverse panel of experts that can provide perspectives, from an investor standpoint, entrepreneur standpoint, and also a major corporation as well. And so as a result, I think each panelist can provide a different perspective based on their background. And with that, maybe we can just go down and have everyone explain a bit about your background and also in connection to that, what you see happening in this industry right now, the key drivers of the transformation going on in the car of the future.
Okay, I guess I'll go first. So my name is James. I lead strategy and business development at a autonomous driving startup called Perceptive Automata. Before this, I worked at a company called DeepMap. I helped build DeepMap from the ground up, initially with Mark Wheeler and James Wu. So from the work we do at Perceptive focuses on human behavior prediction. There's a tremendous amount of work in this space around the physics problems, so object detection, tracking, motion, sensing, all those sort of things. But the sort of really big missing piece is how do we interact in a human-dominated road environment, right? So when we look at pedestrians and cyclists as humans, we need to be able to predict what they're going to be doing next. So our AI here at Perceptive basically solves that problem, enables autonomous driving, autonomous vehicles to drive much more smoothly and safely in a human-dominated environment. I think you asked the question about sort of key drivers. So I think for automotive, it's this confluence of software, basically, according to Marc Andreessen, his words, eating the world. So development of AI, machine learning approaches, electrification, and both of those things really disrupting the fundamental economics within transportation and mobility. And so all of these, OEMs are waking up to this issue and are investing massive amounts of capital into this. And I think that's sort of what's driving transformation here in transportation.
Hello, do you hear me? Yeah. Good. My name is Robert Seidel. Thank you for having us here. I'm with Mutus Ventures. That is an early stage seed fund, investment fund for companies in the autonomous systems and robotics space here in Silicon Valley. Some of our companies we do a lot of work in sensors, so we have Quanergy for LiDARs, we have MetaWave for radars, we have Civil Maps for maps, we have MetaWave for large-scale sensor simulation for autonomous vehicles. We even work with ultrasound sensors these days that can produce 3D point clouds for near-field sensing, all kinds of things in sensors because they are the first stage of perception. There's a lot of stages above that, and you are certainly part of a very important one, which is the human perception side. We think that this is a very early stage yet still, even though it's been 15 years since the DARPA challenge in 2004, where nobody actually completed the challenge and most people actually fell over just coming out of the gate. But just 1 year later, we had the first cars completing, and just a few years later, we had Google setting up their own car division. So a lot of things have changed since, but we are really still at the very beginning of this, and we're going to come back to this, but the changes that are driving a lot of this development, some of them have been predictable, some of them are very large scale, but a lot of the details keep meandering around. And that actually provides a lot of opportunities for startups, for companies that see that opportunity and seize it, whether it's with technology or new business models, and to get in there and start new businesses that you didn't even hear about a few years ago. So I think that the time is exciting at the moment for startups because of this upheaval. And in terms of what influences, I want to second your thoughts. The electrification is a huge change because powertrain changes are always large, but when you completely change the powertrain, it's a huge personnel change, it's a huge organizational change. But in addition, because electric vehicles are much simpler, still complicated, but much simpler to build, it lowers the barrier to entry, which means that a lot of other people are coming in, and all your combustion engineering that you've had for 100 years is basically vaporized very quickly. That's a big business challenge. And the other challenge is that the change to software is a huge change. OEMs, car companies, suppliers are hardware people. Their whole DNA, their supply chain economics, their dynamics of building things are built around doing things slowly and one time. And in software, it's fast and all the time change. And it's a huge organizational change, which I think not many companies have yet successfully completed.
Hello, I'm David Segrera. As mentioned, I'm part of the Samsung autonomous driving team called Driveline, located here in Silicon Valley. In terms of my background, I've been with Samsung for a couple years, mostly here at the Samsung Strategy and Innovation Center here in the Bay Area. And our whole mission has been about incubating new businesses through technical development, through investment, partnership, and acquisition. And so in relation to the autonomous driving effort, we've actually been at it for quite some time, even though we only announced the platform about a year ago. And we've made in the ballpark of around 20 different investments and partnerships in this space, everything from many of the sensor type companies that you mentioned, to data, to algorithms in the space, and also testing, validation, really across the whole spectrum. We share that vision that it's going to take quite a bit of coordination across the whole technology stack to really make this a viable solution. In terms of where I came from, I actually came from the aerospace industry initially. I started off as an engineer in both commercial aircraft and in space systems. And in some regards, a lot of the challenges that we're dealing with today in automotive are very reminiscent to challenges and problems we were working on in aerospace for the last several years and decades, to be quite honest. In terms of making these systems robust, making them safe and reliable is a huge challenge. If you think about it today, traveling on a commercial aircraft is over 10,000 times safer than driving in a car. That didn't happen overnight, right? Last year alone, I think we had 37,000 or so automotive deaths just in the United States. That's equivalent to a 747 crashing every week of the year and everybody dying. But we don't talk about that. Why not? I think there's definitely an opportunity for the use of, and lessons learned from the aerospace industry of how do we build these robust systems, how do we make them more safe, and go to this world where that just doesn't happen, that a car accident is as rare almost as a plane crash. In terms of the drivers, I think this focus on safety is a big piece of it. I think there's serious technology developments that still need to happen, and my colleagues here have mentioned a few of them in terms of AI, implementation, simulation, and verification of these systems. I think in the marketplace today, you see really two different camps. You see groups that are focused on level 4 or 5 development and doing a fully integrated system, and we see some very positive traction from companies like Waymo and Drive.ai and others who are testing out these systems. And then you have others that are looking at what are technologies that are going to impact yours and my daily life from ADAS and safety features. I think both are important and will drive the experience that you and I have on a daily basis.
Hi, everyone. My name is John Four. I'm with TrustLayer. I'm also a member of Sandhill Angels, which is one of the earlier stage angel groups here in Silicon Valley. We make about 40 to 50 investments each year. TrustLayer is the project that we recently launched. It's a blockchain startup that focuses on verification of insurance and verification of other compliance between companies. just as you see a lot of innovation taking place with sensors and some of the AI around how a vehicle actually moves, getting to the point that we have these automotive companies need to innovate much faster. The idea of having a generation relationship with one particular OEM manufacturer might not be how the future exists for a lot of the most successful car companies. And so we provide a layer for companies to be able to validate information and share information in compliance very efficiently, so that big companies that are in this space or big legacy companies are able to engage with startups or earlier stage technology companies more efficient.
Well, that's been very helpful. Related to, just following up on the key drivers, it gets to trying to understand exactly what this sort of vehicle of the future is going to look like. And the way I sort of try to understand this by trying to understand what the tech stack will be for that vehicle of the future. And based on what I heard, it seems like there may be like 5 different layers. And I'm curious whether this is correct, or there could be even a better approach. But it's like, what I heard is like you have electrification as sort of the bottom, and then you have sensors on top of that, or other hardware elements that then you have the software AI, and then maybe a connectivity, and then at the very top, business model or government regulations or so forth. So anyway, that's just an early attempt in trying to understand what the tech stack is, but I'm really curious how each of you would think of like what would be the tech stack of the vehicle of the future.
Yeah, so I think there's if we take a really macro view, right? So we have the core technology, the core stack, and then we have wrapped around that, business model layers, and then of course enabling technology like electrification. And if we look at the core stack itself, we typically talk about perception layer, sensor layer first, sensors, then perception. And then we have, mapping that supports real-time perception. And then we get into layers like the stuff that we do here at Perceptive, which is really developing specific capabilities for human behavior prediction, right? So in being able to interpret human behavior, give machines human intuition, basically. And there's different, ways of, and then you have motion planning and path planning and control. So it's different pieces. They're sometimes labeled differently, but I think in this case here, the specifics are not so important. But you're right. I mean, it is the core stack, tech stack wrapped around a business model. Oftentimes you see discussions focusing too much on only technology, and then we kind of ignore the bigger picture and how this fits into the real world. So that's sort of my feedback on that.
Yeah, I just want to emphasize that electrification isn't required for autonomy. You can certainly have hybrid cars or even combustion engine cars driving with self-driving technology and diesel engines even. The trucking is a big industry, and trucking lacks a lot of drivers at the moment, and it's only going to get worse with all our kids ordering Amazon packages. So the demand goes up, the supply for drivers goes down. I talked to a trucking company recently that talking about business models, I'm going to start from the other way down. They hire 107% of drivers that they employ a year. I had to double take on that. What do you mean? Well, we hire more. We replace every driver more than once every year because drivers do not want to drive long haul. That's a real problem for an industry that's growing, right? So when we thought in the beginning it would be self-driving, everybody would, instead of buying their Tesla or Mercedes or VW or whatever, it would be a self-driving one. That picture has actually gone further into the distance because these cars cost a lot of money, and the engineering of these cars to be reliable for 11 years like they're supposed to be on the road right now is very hard. So actually we have other things coming first, namely the fleets and the trucks from a business model perspective. And from a technical, since you asked about technical stack, there is a lot of change still happening. So when DARPA Challenge 2005 happened, we only had one type of scanner, was the SICK laser scanner, was an industrial single beam scanner from Germany. That was it, everybody used that. Pretty soon after that, Velodyne came on, not spare the whole history, and then we invested in Quanergy. Now there are 60 or 70 LiDAR companies. That's just LiDAR. when we talk about radar or mapping or other sensors that the car needs, it's literally a Cambrian explosion of sensors at the moment. That has a huge impact on the development stack and the development methodology of these companies, because you have to be able to change a sensor position, how many of those sensors you use. The 70,000 sensor gets replaced by a $20,000 sensor. The thermal envelope, the power envelope, the packaging of where it goes. These are all factors that evolve over the next 10, 15 years, and that means your engineering department is going to get hit over the head with a new order to change sensors every few months, which is a huge challenge, both from the packaging and the software that's on top of that. So I think from a stack perspective, there's a lot of change and frothiness from below. And then from the business perspective, there's pressures that we are just discovering where the best market fit is. And that will have implications on what the cost and the size envelope of these things are.
I would agree with a lot of what's been said. I think for me, there are two major areas that really need to be developed further in the technology stack to really make this a ubiquitous solution. Number one is harnessing the power of AI in embedded applications. So I think we've had a step function improvement in the way that these sensors and the data that's coming in can be processed. In talking with companies that have been working on perception problems for years, even decades, that were using traditional computer vision models, within a couple months of moving over to an AI framework, they've already improved and they've exceeded their previous work. So that's really astounding. The challenge with it, though, is that the models and frameworks and the compute needed today to run these is astronomical. And what you end up happening in a lot of these test vehicles is you basically are running a mini data center in the back of the car that's running hundreds of watts, that needs to be water cooled. It's just not sustainable. And you try to go to an OEM and say, yeah, we'd like to put this in the car. And they say, are you kidding me? No way. So there's definitely a lot of work that needs to happen on the AI side, both on the algorithm front, but also on the compute side. We've had a lot of improvement with GPUs, NPUs, different accelerators that have come to the market and are coming to the market, which show a lot of promise, where we can start taking processors that can do hundreds of TOPS of compute in very minimal power envelopes. We need to go from hundreds of watts to tens of watts to really put this into a ruggedized solution in the vehicle. So that's number one. Number two is the importance of modularity, openness, and scalability. As is mentioned, there is a multitude of companies that have come to be in existence in the last several years because of the challenges in this space. And as it said, it takes a village to raise a child. I think it's going to take a village to make the autonomous car. It's going to take collaboration across multiple pieces of the supply chain and industry to really make this possible. And how do you do that? Well, to do that, you have to architect that down into the hardware and into the software as well, so that you can add that flexibility to change out the sensor sets as new and better sensors come to the market, as new and better compute comes to the market, as new algorithms come to the market. And so that's, I believe, a critical element for any of these people, any of these companies that want to make a solution in this space. You have to build in that platform, that ecosystem mentality from the very beginning.
One of the areas that we've seen, we've gotten inbound requests from automotive companies that are looking at, that are concerned about the insurance space, which the technology connection here is they're looking to automate certain aspects of the insurance compliance. And what they really are looking at is they're wondering how tokenization is going to be coming down the line at some point in the future. But again, they see that that's like 2 or 3 years down the line, and I think some automotive companies are getting ahead of it because they think that in the near future they're going to be the ones that are going to be responsible for insurance compliance. It's not going to be as it is now, where we all have to have our own automotive insurance, but that piece is going to be changing, and then they look at it and they realize that that's a potentially administrative roadblock for them.
Following up on what you were saying about insurance, I think sort of extending upon that, or safety, that really brings in the area of government regulation, government involvement. Maybe if everyone could just comment on how you see the government or the role of government in driving the transformation of the vehicle of the future, and also how different governments may be acting differently.
I mean, it's a standard issue of we in especially here in Silicon Valley and lots of startups, we have these great ideas, but we have to exercise within this framework, which is always 2 steps behind. One area that frankly, I've seen companies that are just pushing the envelope, and if you wait for guidance, I think it's going to be challenging to get meaningful guidance. So you just try to, at least what we've seen is companies that try to find maybe like 2 parallel approaches at once, where they exist within the current framework, but then they pilot a new model, and the idea that when the government finally catches up, they'll be in a position to just replace the old model with what they've been piloting.
I have kind of a slightly different opinion on that. I think that it's such a dynamic environment right now that you can't just wait and you can't just go ahead and do whatever the heck you want. I think it's an environment where you have to communicate, you have to be involved, you have to talk with the regulatory bodies. And my experience with them so far is that they're very open to discuss. Here in California, the DMV is very much taking a leaning in type mentality of wanting to not stifle innovation.
Even after the Tesla crashes.
Even after that, right? You see, even in the last week or so, they've actually approved the first truly driverless testing in the state of California. That definitely shows that they're wanting to go forward, but they also realize that this needs to be done in a safe way. And so I think those that are innovating in this space also have a responsibility to push that envelope, but to be measured in their response as well. They need to be responsible in how they're approaching this and realize that many of the technologies do have limitations, and be upfront with that. I think also in terms of policy, it varies a lot by region. And so there's not a one-size-fits-all for this either. In the United States, there's different acts in Congress that are being contemplated to try to standardize a little bit more. I believe that that's a critical part for anyone that's also trying to develop technologies in this space in the United States, is you don't want to have to build one way in California, another way in Oregon, another way in Michigan. There needs to be more of a generalized, agreed-to framework for doing that. Now, if you look globally, it's a little bit different as well. Throughout Europe and many parts of Asia, many are complying to a UN set of policies to go forward with how vehicles should interact. And in that regard, though, you're still seeing country-by-country modifications or some deltas to that. Some countries like Germany are being very proactive in trying to get involved there, but again, it always goes back to what is the UN regulatory requirement. If you look at some vehicles that are trying to come to market, like the Audi A8, they've had challenges in terms of meeting the regulatory requirements across different geographies, and so having.
What exactly is the UN regulatory?
So and I'm not an expert by any means, but my understanding is that it's a set of policies that different companies basically sign up for and say we're going to abide by these general guidelines, and it includes most of the UN and then many other countries as well. My understanding, actually, Korea is one of them that have also abided by the UN terms of policy regarding vehicles. There's still a lot more work that needs to be done, I think, globally. And in the US, hopefully we can get our act together and be an example of that.
Yeah, you said a lot of the things that I would also have said, so I'm not going to repeat them. I agree with them. Just as an example of how different Europe, for example, is from America, Europe has a certification authority. So there's standards that are set, and you have to meet those standards. And you've probably heard of TÜV, which is the German standards validation authority. And if you don't meet those standards, well, then you can't go on the road. And some of the German things that are, or not just German, European things that are harsher than here are, for example, privacy requirements. Anytime a sensor takes picture of a face, I'm sure that impacts your business as well. It can't be transmitted, and there's all kinds of privacy protections in place. You know, when you go to Google Earth, you know, the faces are blurred out. Well, you need to know where the person is looking in order to see whether they've seen you or not. So this is important for the sensors to be able to be aware of that, and how that data is sent up or not is a big deal. That's different here. Here it's self-certification, so the industry basically gets together and says, you know, what is a reasonable best set of practices and standards that we should adhere to, and that at the moment is very much in flux here, and the industry certainly isn't eager to have government tell it what exactly to do. But on the other hand, there is a minimum standard that people are concerned about, because, you know, the big ones, whether it's Daimler or VW or Volvo, they're putting literally billions of dollars of investment into this stuff. And if Lewandowski's or Uber or Tesla or whoever, or Phantom AI, come around and they basically ruin it for everybody. With a startup with $5 million investment can ruin it by going on the road and killing somebody by being reckless, right? And that will reflect in the public domain and in the regulatory domain very badly, and may have a pendulum swing backwards, which can impact billions of dollars of investment. So there is an interest, I think, from the industry here as well, to have a minimum set of guidelines that everybody has to adhere to. And I think Waymo has really shown you know, the way in that respect. They've been quite responsible, I think, and people are starting to see how far ahead they are in some respects.
There's sort of an inherent tension in this industry right now, because the technology that we're developing is so new that there isn't really any regulation, or there's no kind of certification that can actually prove that, you know, it meets X, Y, and Z safety standards. So functional safety is a big issue in the industry, in automotive in general. ISO 26262 is a software-based certification system, functional safety system that the industry typically applies. But that ISO 26262 isn't really sufficient for autonomous driving type software. For example, the whole use of machine learning and deep learning models, which is basically, crudely speaking, similar to the way we as humans learn about something, right? It's when we learn how to drive, or a teenager is learning how to drive, he or she isn't following preset rules and a checklist. It's something that happens up here in the brain, and we can interpret the world, we can follow certain basic rules, road rules, of course, but there's a tremendous amount of learning that happens and capability develops without being able to really say, okay, 1 plus 1 equals 2. And I think countries that approach this challenge in a more with more interference can actually truly stifle development of this technology in their particular countries. So this whole dynamic around certification and regulation is going to be really, really important when it comes to the competitiveness of nations. And there's different cultural factors. Europe tends to be a little bit more, well, quite a bit more proactive. The US here is a little bit more loose in general about things. You know, maybe Korea might be tighter, Japan might be tighter, but it will definitely impact the way this industry and the capabilities for autonomous driving are going to develop in those countries. If it's too tight, you stifle it. People are going to be too concerned about, you know, developing this technology, using machine learning, for example. And there's no way around this. We have to use machine learning systems to solve this problem. Traditional approaches to software development and use won't work in this case. It's just too complex of a challenge. Same with data, right? Data rights and laws and those sort of things. So if Europe is too tight about being able to just simply drive around and collect sensor data and then use that sensor data to develop your technology stack, and you have all these hurdles to jump through, and you have to, you know, do lots of things to this data to mask information because of privacy concerns, then suddenly you might not be able to actually develop or take that data and use it for sort of the training that you need for your machine learning system. So it has all these implications. Regulation is actually an important topic.
Can actually, I want to make one follow-up. It occurred to me while you were talking, and that is in the old-time certification and functional, bottom-up specification. You validate each module, and you validate the integrations. With software, that's very different because it's a huge tangle of complexity. And what we really need is kind of a driver's license for the self-driving vehicle that somebody can put it on a test stand, and that is happening in simulation.
Yeah, that's kind of the approach actually you see in China. They're actually giving a driving test to the car before they let them drive.
Because you can't drive hundreds of thousands of millions of miles and hope that the things that you need to encounter and show that you work against actually happen. You have to do that in simulation. And Google, I just want to bring up that one example. Google, and people are starting to, the people in the hardware and OEM and traditional businesses are starting to realize how much of a difference that makes. Google, for every mile they drive in, there are many vehicles that we see driving around here, they drive 1,000 miles. 1 to 1,000, factor 1,000 in the simulation.
And I think that simulation is a key piece of this puzzle, right? If you look at even testing in previous for major OEMs, 95% of all their testing is all done simulation. Very little in comparison is actually done in the real world. We need to get to a similar type paradigm because it's impossible to get all the use cases to drive enough miles to even quantify what are the miles to drive, what are the use cases to test at this point to say that something is safe or not.
Like in aerospace, you come from aerospace, right?
Yeah.
That's very common there for development, for validation, and then for certification. So.
Yeah, one other comment I wanted to make too is although the regulatory environment is still very nascent and new, there are indications of where the market is going. So if you look at the new car assessment programs, NCAP, in Europe and the US and others, these are more market-driven bodies that are trying to say, where is the future? Where do we need to go? And so they're talking to the OEMs, they're talking to people developing the technologies and say, what should we be doing here? What constitutes a level, a 5-star type rating for these functions? And so you're seeing that in many of the level 1 and 2 systems that are coming to market now, and they're talking of what does that mean in a level 3 and beyond environment as well. And so they publish roadmaps, they have roadmaps that go out to 2022 and beyond, and the time to influence those is really now. And so anyone that is also wanting to influence this direction from a regulatory policy, a good place to start is with these kind of informal industry groups and make a difference there, make your voice heard there.
Just maybe one more quick comment on this issue. It ultimately comes down to society deciding what kind of risk-reward equation, right, is appropriate in this case. So as a society, we've decided, at least in the US, a 16-year-old, a teenager is allowed to drive, right? So that's a decision the US made. You will not do this in Germany. Germany is 18, right? And other countries like this. So so we're giving 16-year-olds car keys and they can go and drive. Now, of course, at the beginning, they're just simply not good enough, right? It takes time for them to learn, to get better over time. But ultimately, certification and regulation for autonomous driving will follow a similar kind of political process, right? Society will ultimately have to accept this technology and accept what kind of regulations are, where's the risk-reward equation, basically, right? How much risk are we willing to take given the upside that we can transform transportation and all the benefits of it? So I think every country will also be somewhat different along those lines. Yeah.
We were talking about different countries and the responses, whether US or Europe, but one country we really I didn't hear a lot about is China. And so if one of the panelists can just talk more about, what is the Chinese approach to this sort of risk-reward, since they'll probably be a major economic player in this industry as well, too.
I'm not a China expert.
I don't claim to be a China expert either, but I've been to China and I've visited with many of the companies there, and I can make some observations to what I see. So it seems in regards to the way the Chinese government is looking at it, they do. Privacy, even use of roads and implications for people to get hurt, right? So in terms of what I observed is what we see is the Chinese government trying to support through access to data. So what I found there is that companies actually had access to sometimes government sets of data, which have webcams, they have traffic monitors, they have a huge amount of information at their disposal. And so what we're seeing is that the development of those algorithms is skyrocketing. It's doing really well. So you're seeing a boom of AI-related automotive companies in China. Number two is you're seeing some areas where they're actually creating these kind of autonomous zones. So in like the Shenzhen area, they actually have an area they call Bio Island, where they have made that an autonomous driving island. And so you have a couple companies like Jingxi and Pony and others in that region that are taking advantage of that and getting more real world experience. In terms of the exact policies and regulations to get it approved, it's still unclear to me exactly how they're going. But what I'm hearing is they have some kind of driver's license type exam that they want to give these companies to pass in order to ride on their roads. I don't know if anyone else has experience there.
Well, the data piece is vital, right? I mean, if you're doing machine learning and you're in Europe, and you're versus machine learning and you're in somewhere in China, just the volume of information that you have to help improve your systems, it's night and day, and it's only going to get, the differentiation is only going to get worse. On a side note, if anyone's interested in this, I just finished Kai-Fu Lee's book on this topic, Super AI. It is fantastic and focuses just on this exact topic. A little plug for
I'm just wondering, I just read this morning a report that Chinese surveillance technology is, of course, increasing very quickly, and they want to make sure that, they've captured everybody who's jaywalking across the street, and facial recognition technology maybe not good enough because it's too far away. They have now gait recognition technology. So that overlaps a little bit with your field of work, doesn't it?
Yes, different application. So we're not working on yes. I mean, in principle, yes. It's taking observing humans, right, in different environments and using that sensor data, camera data, or whatever, building machine learning models, and then being able to, do massive surveillance, right, and they have certain objectives for that. In certain places around the world, I think, for better or worse, that's just the way the system works. London has a massive amount of cameras for historical reasons and terrorism, IRA, and all those sort of things, and that's accepted in a place like even the UK, right, like London, and they do the same. They actually do facial recognition and they track.
Do you think that will have impact on the technology? I'm sorry, I'm not in charge of my technology here. Sorry, my son gave me this. The technology stack, when you have inside-out sensing, which is what we do here, versus when you have outside-in sensing, which in a surveillance society, it's easier to get the data from the government, so to speak. Does that impact the technology stack?
Absolutely. I mean, so there's two sides to the coin, right? So, for example, for mapping data in China, you can't just go out and strap some sensors on the roof and do your own mapping. It's tightly controlled in China. There's like a handful of licenses. And if you're caught
like
doing
five, it's not very many, very few.
Yeah, up to 5 to 10, something like that. If you're caught mapping in China anywhere, you're in deep trouble, right? So it depends on it's not always, and which is actually stifling, because HD mapping is core to actually developing your system, right? So, but then if you can just simply collect sensor data and you don't have to care about privacy, that's great, right? From just purely tech development. Europe, you can't. It's going to stifle development because of that. But then you can do mapping in Europe without too much of a problem. So I think there's all these trade-offs. Everything's going to be different. Here, you can do both freely.
There certainly is a lot of capital available for development. There's a lot of capital that came before the last Party Congress came over here to Silicon Valley, billions of dollars, and some of them went up in smoke. But there's a lot of serious Chinese companies. Tencent, I just heard, set up a AV lab here as well. So it's not just traditional car companies, of which China has many, but also there are large software companies that are investing heavily. Baidu just had a deal with VW.
Well, going into now the area of sort of where would be like future investment, the sort of like the area, part of the tech stack or business model you think that needs the most help. I think, David, you already alluded to one like embedded AI. But be really curious to get everyone's thoughts on, as we're moving to the vehicle of the future, what is the area that, we should potentially target as investment? And obviously I'm an investor, so it's an area that I'm interested in. Thank you.
Robert?
Well, do you want to give us your opinion?
I'm learning about the vehicle. So
well, I think across the whole stack, there are opportunities for investment. We certainly start with the sensors, and we like to invest in things that have software and service components on top of that, because a vertical stack kind of ensures that there's a longer life beyond the pure hardware of the sensor. The fact that these sensors generate so much data nowadays that has to be processed also generates opportunities for CPUs, GPUs, TPUs, new kind of neural processors that have thousands of the power needs, because you can't have as much power taken for your compute as for propulsion, because it halves the vehicle working distance. Yeah, I think even in insurance and in transactional safety, there's a lot of innovation, because insurance companies have had to insure distributed risk, where it's a bad driver or a local accident or bad weather or something like that, and now they insure kind of fleet risk. If there's a bug in a fleet, it's instantly known to everybody around the world, and that's a huge liability that moves the needle from zero to into the red very quickly. And so that has impacts on how the technology might, the insurance might view the technology and whether they insure it all, and what the technology has to prove before it gets insured.
Yeah, there's one, speaking of that, there's a lot of good things about that, right? Because it means that if you find out that
Transparency.
Yeah, if you find out that for whatever reason, if the system sees a deer, it has problems, but I don't know, some like very niche thing, so it can fix certain things. On the flip side, it's guilty knowledge. So if it doesn't fix those things immediately, now it's really in trouble, because it knows that there's this risk, and that's where the automation piece comes in, where trying to figure out these workflows to like improve the systems after the fact, and not just for the technical piece, but the kind of the back office piece, and working with the manufacturers or the OEMs here.
From my point of view, I think it all comes down to the data. I think AI is really the key of this whole thing, and AI runs on data. So a part of that is the acquisition of that data through sensors, which we've talked a little bit about, and I think there's been a fair amount of investment in that space. I think, as I mentioned earlier, the processing of that data is still a big challenge. I think the how do you manage that data is also a huge issue. When you have vehicles that can collect terabytes of data per day, per hour in some cases, what do you do with that? What's even useful there? How do you process that? How do you annotate that? Companies are spending fortunes in annotating of data to train their AI algorithms. There's need for improvement there. That then also feeds into the data pipeline and into simulation. How do we then use this information that we're getting to verify that these systems truly are safe? I think there will continue to be a need there. There are historic simulation companies out there that have been looking at different elements and pieces of it, but from my point of view, there's still room and growth there to do more. The other piece of this too is from the data fusion perspective. Taking the different sensors and sensor modalities out there and getting more information, because you have the LiDAR and the camera and the radar, than any one sensor individually. And then also getting context of the environment and the other vehicles. What are they seeing? How are they sharing that information? That interplay of data within the vehicle, within your own data pipeline, and then also across the ecosystem are going to be areas that will continue to grow, in my opinion.
So I think one way I look at this investment challenge is talent, right? Follow the talent. This problem is so hard to solve for the real world. We could probably create, using open source software and some off-the-shelf stuff, we can create a robotic system, a self-driving system that drives in a parking lot. There's actually a lot you can do today if you're a bunch of PhDs, and you can do some interesting work. But building something that works in the real world is a whole different ballgame. And there is a lot of noise in this space, and a lot of people that are claiming they know how to do X, Y, and Z, but actually they don't. I would estimate that, for example, for mapping, to do mapping right for L4 and L5, there are maybe only a dozen people in the entire world who know how to do that at scale for L4, L5. Now, many people would maybe might disagree with that, but I strongly encourage you to follow the talent. If you find the right talent, it doesn't matter if it's the sensor stack, the perception stack, mapping, you name it, or our piece. If you find the right talent and they know what they're doing, you can invest and you can win. You can have a good ROI. If you follow more of a theme-based sort of investing approach and say, okay, look, I'm looking for the best possible simulation company. Okay, these guys look good. I'm going to invest in these guys. They're going to have some kind of exit. I think it's going to be challenging because you're not looking at how good the team is. And very important here is not just the founding team or the quality of the founding team in terms of can they execute on the technical challenges, but are they able to then attract the next 10, 20, 50, 100 experts or true talent in that space that can help them build and scale this system. So, and this is why Silicon Valley is so dominant in this space, right? So AI talent is typically around here, right? And so if I'm a super smart AI guy, I want to work with people like Chris Urmson, right? I want to work with certain people that have certain backgrounds and experiences in this. And there's sort of a joint way of working. It's just a very, very big challenge finding the right talent. So I think I would just emphasize that in anything you do. If you're interested in this space, follow the talent. It is so elite in that sense at this point.
I've actually got a follow-up question for you guys. What areas, especially in the AI piece, do you see this as like multiple companies can be successful, or do you see this as like a winner-take-all? Because I see like LiDAR, if you've got 60 companies in LiDAR, you might be smart enough to choose the top 6, but if only 2 are going to be successful, that's a pretty risky thing.
Yep, seed stage investing is risky, but it also has its rewards, I hope so. Yeah, but there's a big diversity, and it's just like the Cambrian evolution. Before the Cambrian explosion, we were basically all bacteria and slime molds, and afterwards, every modern body plan plus a whole bunch more appeared, and most of those evolved out and are no longer around. So there will be definitely a trimming of the tree there for sure.
So I think at the we're going to see, I think, only a handful of players that actually deliver the whole system, in the near term at least. And so I think there'll be a concentration initially, and then over time, the capabilities spread, know-how spreads, right? But there's a tremendous amount of opportunity, sort of, if you're picking certain pieces of the stack, you can still be very successful, even, either eventually being acquired by one of those guys or supplying to one of those guys. I do think there'll be a lot of pruning. That's inevitable, right? People are talking about hype cycles and things like that. But I think there's going to be a pretty interesting set of, and there's different applications, right? A sensor that works really well in terms of performance and cost trade-off for last mile delivery is going to be maybe different to a sensor that's needed for a consumer OEM, right? Type application. So there's going to be a lot of different flavors of this and geographic differences. But I think there's definitely going to be a significant pruning at some point. So that's why I picked the talent.
Yeah. Yes, definitely. Team, timing, technology are the 3 T's that are important, I think, for us from an investment point of view. But even on the neural network side, there is so much development still. Convolutional networks. Oh, okay, that's already yesterday's. We need temporal. We need spiking neural networks. There is a lot of change in that space. And at the moment, like you said, the first players that have complete solutions will have built everything themselves, every piece of that stack, and they've cobbled it together. That is an extremely expensive and high maintenance type of approach.
And not super scalable either.
No. So people like you, Samsung, which build technologies and ecosystems, will become tier 1, tier 2 suppliers of that, and we will go back to a longer supply chain. But at the moment, because of the speed of innovation, the shortening of the supply chain pioneered by Tesla has really gotten results faster, but it is not a sustainable long-term model. I think eventually the market will again go to a longer supply chain, and component suppliers in the middle of the stack will have a livelihood.
And I would just add to it, I think that's why these alliances and partnerships that you see forming are so important, is because in the long run, I think that is where the market's going to go. You're right, the market can't sustain 60 LiDAR companies. It's just not feasible. So there will be some coming together, some recognition of platforms that are going to win in the marketplace, but those will likely be in conjunction with other people in the system. And so you're seeing OEMs partnering with technology players, partnering with go-to-market players, and you find these clustering. And it's changing every week. It's highly dynamic, but I think partnering and going together in this space is critical. And for the long term, that will be the way that you win.
Well, thank you very much. This has been very enlightening, at least for me, so I appreciate this a lot. I actually see we're out of time, but maybe we can answer a couple of questions that people have in the audience. Yes.
I'm KRS Murthy. I noticed that the panelists covered quite a lot of topics in law, ethics, information sharing, and I don't know how many of them are lawyers, people with experience in the domain. So that's what I'm afraid of, because everyone starts making opinions which are not really facts, which are not how the government works, at least in USA here, and at the state level and so on. And so even talking about insurance, the issues that I have is that how much money has Google put in an insurance corpus fund somewhere to be able to cover? You know, these are more important at the high level to start with, and have a legal team discuss with some automotive experts as well. And so what is your opinion on that kind of an approach, rather than, you know, novices talking about law?
Well, I think maybe I'll just take that. You know, clearly when you're going in specific about the legal programs and so forth, it's always good to bring in lawyers, and I think that's, you know, everyone here, whether it's insurance or something, when you go in and to specifically dealing with government, lawyers will get involved, whether companies like it or not.
And I would say Google, for example, has brought in very early on somebody from NHTSA, and they have a whole team, partly on the lobbying side, partly on the interaction side, to stay connected. And then in terms of government, namely NHTSA, Federal Highway Administration, DOTs, talking to the technologists and talking to the companies, there's a very good conference every year. It's called AVS, Autonomous Vehicle Symposium. Last one was in San Francisco, where those three parties come together. And quite unusually, I think, like you mentioned, people from these government agencies come and say, what can we do? Should we do it now? Should we not do it? Should we do it later? Should we do it federally? Should we do it locally? Bernard Serrano is the DOT chief here in California. He's always at these meetings. So I think there is definitely an interaction at the moment. It's not adversarial at the moment. It's really quite constructive. It's just a difficult problem. It's not like there is a clear answer to this.
And I would just add, from our perspective, we realize that it's a nuanced and challenging space. We have a team that's looking at it and working at it. But it's also interesting when you talk to the people making these rules and laws, they don't have the answers either. They're still trying to figure it out. It's very much an open dialogue. It's a discussion at this point, and everyone's trying to figure out what the best solution is going forward.
Like even the simple question of how safe is safe enough can keep a room like this entertained for days. Yes.
Well, I think, I guess yes.
It's hard to see. I think that hi, I'm BJ Kim from Mando Corporation, Tier 1 supplier from Korea. I think my question is related to that, previous question. I see, in the perspective, the Tier 1's perspective of view, we see the ADAS market has been grown maybe by virtue of the driving forces from the safety-related entities or associations, such as Euro NCAP or Korean NCAP, China NCAP, and even NHTSA NCAP in here. But when it comes to the autonomous driving, I think, as we have more kind of news related to the fatal crashes out there, some voices we see some voices that we may need some kind of evaluation entity or company who can certify the level of safety on the cars or the kind of autonomous driving features. So I'd like to hear about that point on the panel list.
Yes, definitely. Hi, BJ. There will be a oversight group or entity, government most likely, that will certify and will have to track data and investigate and all those sort of things. There's no question about it. The question is though timing, how tight the rules are, what type of rules, right? Who's in that group, that entity, who makes those decisions, and I think that's TBD, and partly because the technology is so new, and it's going to be outcomes based. I don't think it's going to be like a traditional automotive, which is you have to almost like look at the code and certify every line of code. I'm exaggerating, but the point is you have to be really like 1 + 1 = 2. You have to demonstrate every little piece. That won't work in this case. So it will have to be outcomes based, and just being comfortable with that as an approach. But absolutely, there will be, and that will evolve, and every country will be different, along those lines.
So just to add to that, in Europe, in Germany, I should say, there's an initiative called Pegasus. It's industry-wide as well as involving FKA and the DLR. And it's basically developing the framework for establishing what to test, how much to test, who tests, what tools to use for testing, around scenario-based testing, simulation, as well as in the real world, and how to validate the tools that you use to test, because if you spend thousands of billions of hours, as in Google's case, using simulation, you have to trust the simulator, you have to trust your sensor models, and that is new methodology that we have to develop. In Germany, that Pegasus project is 4 years long. It's nearing its end. There's already a follow-up. It's migrating over here. There's a working group over here now as well that's looking into, okay, how can we not just talk about it, but actually do something about it? But these things will take time. In Germany, it's focused on freeway driving, level 4 freeway driving. Here, the attention is probably more for urban driving, because that's the use case is more apt here. But so there are efforts underway, I would say.
Just maybe one more quick comment on this issue, if I may. Just there's this. Some people argue we should have standards bodies, right? Why don't we just start from day one, basically defining certain standards, and everybody can just work towards those standards? The problem is, typically, if we do this too early, you're stifling innovation, because the established large companies will tend to dominate those standards bodies. They don't necessarily have the understanding or talent to know actually how to develop this technology correctly. And it's in their interest to do it the way they know how to do it, right? So standards, in my view, in any sort of codified fashion won't happen for the next, say, 10 years, or shouldn't happen for the next 5 to 10 years, because there's so much innovation going on, right? So in mapping in all these different parts. So I think it's very important that we don't define standards and force the industry to do X, Y, and Z too soon, because that will kill off solutions that we need for this.
But sorry, every time you say something, something else occurs to me.
I hope that's a good. I hope it's a
Yeah,
good thing.
you mentioned the bottom-up approach, which is validating each line of code, and the whole ISO 26262, which is functional safety from the bottom up and ensuring that you have the right processes in place. It does not scale for the complexity of problem that we have at the moment. It was built for a time when you had automatic emergency braking and lane change warning as a single sensor, single ECU, a single piece of software, and then you put that aside. We need kind of outside-in, results-based testing, as you said. It's like, does the whole thing actually work? And that's different methodology than what we are used to. It's they're going to turn the lights off.
Well, thank you very much. I think I appreciate everyone participating and attending. Thank you.